Welcome to the Education for Next Generation. This is Sravanti, welcomes you to the topic of chemistry today, that is the structure of atom. You have studied in your lower classes about an atom and about the discovery of atom and the fundamental particles which are present in an atom. The atom is an indivisible particle, the smallest indivisible particle, which consists of subatomic particles. Subatomic particles are the particles which are present inside an atom. They are electrons, protons, neutrinos, antineutrinos, positrons, mesons, etc., etc. Now, the characteristic property of an atom depends only on the presence of protons, neutrons and electrons. That is why they have got that much of importance in studying about the structure of an atom. The physical and chemical properties depends upon the protons and the neutrons, while the chemical properties depends upon an electron. So based on that, various research or discoveries, experiments have been done about the structure of an atom. The very first theory proposed by J.J. Thomson, considering the structure of an atom as a thumb pudding model or the resin pudding model or the watermelon model. After the failure of this J.J. Thomson's experiment, Dalton has proposed the theory, then after that Rutherford. After the failure of Rutherford's atomic model, Bohr has proposed the structure of an atom. Now before going to the structure of an atom or the atomic model, let us discuss about the property of an electron or the spectrum, which is related to the light, etc., or the whole property or the nature which we are seeing around is because of this spectrum only. So what is this spectrum first of all? So before proceeding further, what is there in a spectrum, let us discuss about it. Let us study the electromagnetic wave. What is a wave? How these fundamental particles are traveling, how these light radiations are traveling. So we all know that when a stone is thrown or a pebble is thrown in a standing water, in a lake, it is observed that the ripples are moving around or the ripples are moving. It is because of the vibrations. You all know that sound does not travel through vacuum, but the light can travel through vacuum. That is the reason why we can see someone present in water, but we can't hear what the person is saying being in water. So the radiations, the waves are obtained. So the characteristic property of light is in the form of a wave. Why? Because the light travels in the form of a wave. Why we are seeing or able to see the light? You might have seen in your childhood days or now also, somebody, the one who comes on the cycle to sharpen the knife. When he pedals the cycle, this knife when it is being repeated or kept against the disc, the sparks are emitted. It is because of the vibration between the disc and the knife, the sparks or the light is emitted. Also you have seen that when the welding is being done, like the metro work is going on, the workers or the laborers, the welding job, when they are doing the welding of the tracks or joining some metal rods or sheets, they use some gas or a flame. When the flame hits or to cut a metal, this flame of high energy is being passed or supplied on it, because of which the metals are being cut. Or when you are hitting the metal rod with a hammer, sparks ejects. It is because of the vibration between the metal rods and the hammer. In the same way, when the light is scattering from the sun or the light is traveling, it travels in a perpendicular manner. and during the traveling, when the light is traveling, it is traveling in the form of a wave, the particles, dust particles. Now during that motion, it is possessing the electromagnetic wave, it is possessing the electric field and the magnetic field, which are traveling in perpendicular direction to each other. Now when they are traveling, you can see they will travel in this manner. When they are traveling, they are colliding with each other or vibrating or rubbing with each other, because of which spark is emitted. Because of this reason, the light is possessing the electric field and the magnetic field. See here, the magnetic field is traveling in this direction, the blue color shade, and the electric field is perpendicular to the magnetic field, the orange shade. When these light radiation and the electric field and the magnetic field, they are hitting with each other, they are rubbing each other, they are vibrating within each other, because of which sparks are coming. This is the reason the light is possessing the electrical property and the magnetic property. That is, it is showing the electric field and the magnetic field. Now, the energy which is emitted from the sunlight, like you take example, from early in the morning, let us assume that the sun rays are passing into your home through a fine hole, or that is the surface of your roof. From that roof of a fine hole, it is coming in, or from the ventilation, from the window, it is passing or penetrating in. It is observed that the dust particles like this, some dust particles are observed. Early in the morning, you can view this one, which is traveling in the form of a wave. The dust particles are passing by, which indicates that the light is traveling in the form of a wave. Studying about this energy or the emission of radiation, Max Planck proposed a theory called as Planck's quantum theory. According to this theory, energy is emitted or observed in the form of small packets or bundles. Those energy packets are called as quanta. Because each energy packet is possessing some fixed amount of energy, that is why this is called as energy is quantized. Why it is called as quantized? Because each packet or each bundle of energy is possessing some fixed amount of energy, definite amount of energy. That is why it is called as energy is quantized. So according to Planck's quantum theory, the energy is emitted or observed in the form of small packets, which is called as quanta. And because each packet is possessing some definite amount of energy, it is called as quantized. That is, the energy is quantized. The mathematical expression for this Planck's quantum theory is E is directly proportional to the frequency of light radiation. E is equal to h nu, where E stands for the energy of the light radiation which is emitted or scattered on the surface of the metal. H is the Planck's constant, which is equal to 6.625 into 10 inverse 27 erg seconds, or 6.625 into 10 inverse 34 joules seconds. The CGS units or the SI units of measurement of Planck's constant. Now, according to this theory, if a graph is plotted between the energy and the frequency of light radiation, it is observed that the wave is traveling to a maximum distance, then again it shows towards the lower wavelength. Or you can also take in this manner frequency and the wavelength. This is considered to be as the energy also. In the sense, any object when it is being heated, with increase in the energy, the wavelength is increasing, it goes to the maximum level, again it starts shifting down towards the lower energy level or the lower wavelength, which indicates that any object, like you take example of an iron rod. When an iron rod is being heated, first it shows the violet color, then indigo color, then blue, the green, yellow, orange, red. It keeps on becoming deeper and deeper. The color becomes thickened, or it becomes deeper and deeper red. In the end, it turns into a grey color, the white color. Means after reaching to a maximum level, it changes the color, and after turning its property, losing its property, it starts shifting down to the lower wavelength or the lower energy level. This is Planck's quantum theory. According to this theory, you can express it in the form of this graph. So, this is first wavelength, second wavelength, third wavelength, like that. Means any object, like you take example of coal also. A coal, when it is being burnt, slowly and slowly it gains the color. In the end, it gains the red color, that bright red color. After that, it turns in the form of ash. Means it is losing its burning property. That is the Planck's quantum theory. Energy which is observed to maximum extent, it reaches to the peakest level, the highest level, the peak of the wave. Then it starts shifting towards the lower wavelength. This is Planck's quantum theory. So, any object which absorbs, it will burn to that extent only to which it has the capacity of gaining the energy. After that, it starts shifting towards the lower wavelength, means it starts destroying itself, converting itself in the form of ash or powder, black substance. So, according to the Planck's quantum theory, energy can neither be created nor it can be the energy is emitted or observed in the form of small packets called as quanta. So, the relationship is E is directly proportional to the frequency of radiation. This is the characteristic property. Now, we have discussed that the light travels in the form of a wave. What is a wave first of all? When light propagates perpendicular to the direction, okay, of the axis, means the electrical field and the magnetic field are perpendicular to each other, they are moving in the form of a wave. A wave is possessing various characteristic properties. One is the wavelength, which is denoted by the symbol lambda. The second one is frequency, denoted by the symbol nu. Third one is wave number, denoted by the symbol nu bar, and amplitude. So, what is wavelength? A wavelength is the distance between two successive crusts or troughs. Like, let us take this example. I am drawing the surface of the water or a layer. I am drawing a wave over here. The distance between the upper part of this is called as a wave. The upper part of the wave is called as crest. The lower part is called as a trough. The distance between two successive crests or two successive troughs is called as wavelength. It is denoted by the symbol lambda. Now, what is frequency then? The number of waves or the distance travelled by the wave in a given time period of t seconds is called its frequency. Means, if you assume that the time I have given to the wave is 1 second, so how much distance has been covered or has covered by the wave is called its frequency. It is denoted by the symbol nu. What is the relationship between the frequency and wavelength? As we know that E equals h nu. Nu equals c by lambda. Nu is the frequency of light radiation or the intensity of light radiation, the thickness, the brightness of the light radiation. Lambda is the wavelength. The unit of wavelength is meters or centimeters, nanometers, and the unit of frequency is hertz or cycles per second. So, the frequency and wavelength are inversely proportional to each other. Nu equals C by lambda. Then what is C? C is the velocity of light, which is equal to, C is equal to 3 into 10 power 8 meters second inverse, or 3 into 10 power 10 centimeters second inverse.